This is the final video, part 4 for August 19th, August 22nd. We're looking at all 6 trig functions. We're evaluating, we're simplifying, all this good stuff. In video 3, we ended by looking at how to simplify cosine and tangent, adding those two, secant minus 2 sine, and doing all of that. If you flow to that next page, last little piece here of what we did on Monday, Tuesday, if you were at 1A, we might not have gotten to because of due to the circumstances that occurred that morning, but we'll go over it on Tuesday, the 23rd. But here, we want to look at any angle. So for example, this angle here, if we have theta, theta is right here in this piece. We want to figure out if theta starts at our x-axis and ends at 4, 3. How can we figure out sine, cosine, tangent, secant, cosecant, and cotangent of that angle? Well, in class, we decided we could do a similar thing that we used to develop the entire unit circle. And that is, I'm going to draw it over here eventually, but if we draw a dotted line straight down, then what we have is, and draw it, what we have is a right triangle. Okay? Now this point is 4, 3. Hopefully you can see that. Well, similar to what we did with our unit circle. 4 is our x-axis. That tells you to go to the right or to the left or horizontal. So that means this side here is 4, which means our dotted line, because it's going straight up or down, is 3. So you have a side of 4, side of 3. Now the idea is to figure out what our hypotenuse is. And what we discovered in class, what we talked about in class, is we can use Pythagorean's theorem. So if we call this C, we'll figure out what C is. We can say that a squared, let's call that 4, plus b squared, let's call that 3, equals c squared. And so we get 16 plus 9 equals c squared, 25 equals c squared. And then we take the square root of both sides. And c is equal to 5. So we can figure out that, excuse me. Now we have our sides. Now the question, if you look here, where is theta? Well, theta was this angle here, which means this is our angle theta down there. And so now we can keep going. We say sine of theta equals cosine of theta equals tangent of theta. Well, if we're looking at theta here, we know sine is opposite over hypotenuse, so opposite is 3, hypotenuse is 5, so sine of theta is 3 over 5. Similarly, cosine is adjacent over hypotenuse, which would be 4 over 5. And tangent is opposite over adjacent, or 3 over 4. And now that we have these, we don't need to remember the quote-unquote definition, if you will. All we really need is cosecant of theta. That's related to sine. If you go to the front page of our notes, cosecant and sine are related. But that's just the reciprocal, so that's 5 over 3. Secant and cosine are related. That's the reciprocal of cosine, so secant would be 5 over 4. And cotangent of theta similarly would be 4 over 3. So there we go. We use the Pythagorean theorem. We use a similar technique that we use with our unit circle to figure out if we're given this angle, we don't know what the angle measure is, we still can figure out what sine, cosine, tangent, cosecant, secant, and cotangent are of that angle. One more. I'm just going to get you started on this one, and then I think the other two would be similar. So we can notice here that this angle theta goes all the way around this time to the third quadrant. But if we draw our triangle, I'm going to try and do this here. Okay. Sorry if you can't see that line. We only get part of theta here, not all of theta. But that's okay. We can still use it in the same manner. So I'm going to draw our triangle. Not the best one in the world, but it'll still work. And our point is -8, -15. -8 is our x, so this would be -8 here. -15 is our y. And now we just need to solve for c. (64) is -8 squared. 15 or -15 times -15. Oh man. 225 equals c squared. If you were to add those two, you get 9. 289 is equal to c squared. And if you take the square root of both sides here, $289. Now I'm doing something really quick because I bet that, give me 1 second. So we know C is that, but I bet, yeah. If you were to put a square root of 289 in a calculator, you would get 17. So we get C equals 17. Now we're back in the same dilemma. Here, theta was all the way around there, but we can just use this angle here. And so now we can find sine, cosine, tangent, cosecant, secant, and cotangent. Quickly, just for time, theta, opposite hypotenuse, so -15/17. Cosine, adjacent over hypotenuse. Tangent is opposite of adjacent. Notice these are both positive, so we can just say that's 15/8, or negative. Negative divided by negative would be a negative or positive. And then we take the reciprocal. 17/15, -17/8, and 8/15. And those are our 6 trig functions. We'll go over this again on Tuesday or Wednesday, depending on when I see you. Thursday and Friday, remember, August 25th or 26th, whenever I see you, will be your first assessment, and this will be on there. If you have questions, please feel free to email me, contact me through the website, Remind App, all of those things. Hopefully this was helpful, and I hope to see you in class soon.